So number 2. So where did we stop? RAM 7400 megahertz of incrementation and stuff. Where I would say, like RAM of 6000, what was that, 400? 6400, when it's not performant RAM and literally writing there that XMP profile or something is supported for like 67 or something, that's really actually garbage on the market, because 76 on the last digit, which is not referenced here, is again there. 76 is on the graphics pipeline on the PCI. When that's not writing that there's 6400 megahertz and the last digit is supportive of 76, then you can literally throw that RAM stick into the garbage, because that will never run a real system. But the problem is not just because when you make that on 6000 hertz or something, which the support usually breaks down, like seen here, because the baseline of the LGR platform is 4800 megahertz on working state, and on support state 3600 or something. And 3600 platform, which is usually referenced as the correct answer for a long time, which got replaced literally like 1 year ago or something, to 4800 is the standard now. But these all have to support 3600 and 4800, and that's two different of profiles, and that one is profiled for 6400 megahertz, which is a performance mode of 3600, 4800, and when you go down from the 6400, you lose the performance feature of the support of the 3600 and 4800, and you have like the PCI lane from RAM down to the board over the graphics card is not in synchronicity anymore, and there's very little possibility that you can actually make the device running with the last digit 76, which is again literally right there behind that on there about there 76, and little bit on the left is 72. And when that's not referenced on the 6400 megahertz, you don't need to buy that one, because you won't get it running, because 86 is on the pipeline around the NVMe adapter. Not the chip or something, but the adapter actually. You can, I don't really know 100% the numbers. Currently I have huge HGHG brain damage issues, but 86 sometimes is not on the adapter, but usually it actually is. But you can go 89, for example. 89, 86 can be where right there the screw is too. 86 can be there and there where the screw is. So 86 usually people don't really like, because your RAM synchronizes to that spot where the vortex is, or right there, which is not the optimal place. But 89 goes a little bit higher, which is about there, and literally a bit left of that side are true transistor fuckers, which usually distort your systems then when you actually put 89 on the last digit. But I literally forgot, but 86 is there, 89 is about there, and I don't really know if 92 or 89, but one of these values are below and one is right on the side, and eventually on the chip itself. That's probably a Phison chip or something. I can't read that, but looks like Phison. But Phison chips on 89 is not really that bad. 89 with the Phison chip could run, but usually not really super nice, since you have fans, and these fans are also connected like fuckers in these systems, so that doesn't really work. But 92 is on the right side of the chip, which is usually compatible, since 92 has then contact to the NVMe adapter and the NVMe controller fusion chip, and has a connection to the PCI lane. Since 92 can eventually like interface to there. 96 is then on bit on the right side. I don't think on the height of that, but in between of these two. And 96 is definitely value you can use, but then you have to go to the SSD to actually find the right SSD which works with the controller, with the board, and your RAMs together. And here that is a Fusion chip, that means you need actually a Fusion NVMe, which that should be and should support. That's the older NVMe with worse support and stuff. But that should theoretically work with CL96 on the last digit. And when you go higher than 96, like 102 or 104, then you go towards the direction of these Mongolid synapse clamps, I would call it. That's synapse clamps. And when you go over 96, you put your RAM to where these synapse clamps are till 116. 116 is right in the mid on the right row, the third row, the lowest the synapse clamp, about on that height, where maybe I can show that, probably not, but about that height, where you see the last synapse clamp, about that height on the right side, so below towards the RAM, and that's 116. And then you have your RAMs connected to 116 last digit to that place, and that place. What are you going to do with the system when you RAM actually sockets in like a cotton bag, like zip down momentum? It runs cool like the crypto and stuff, and you zip it down to that place, right? And that's literally that. That has no communication to the power supply. The graphics card can't communicate to it. The processor zaps a little bit, and the VRAM gets hot. On the CL last digit 116, that's literally guaranteed. So the best option is actually to get CL system together, which on the last digit works on 86, which is there about. Maybe there, maybe there. It's different sometimes how the RAMs are built, but usually there, sometimes there, usually also there. In the connection of the PCI bridge of the graphics card, but you actually also have to care for that the RAM actually are interface made, that they actually do connect there, because usually CL86 is there or there, and when it's there or there, then you have to go deeper into the into the configuration. If the other values, which here are just 3 more, and inside the mainboard you have about 80. And these 80 values with pattern recognition, etc., you have to evaluate if they are compatible to the system to give support for the crypto range system, where when you start your system, it's look encrypting and stuff, mock encryption goes on, you go to the operating system, and the partition is locked. And the partition lock crypt should be in support of the RAM, but you actually have to look into the register of the 80 values of these, if these are compatible to the last value of 86, where could be there, etc. If that sector is compatible to the mainboard, so the VRAM don't go into collision mode, so which usually people use ERP ready to turn it on, so the collision doesn't happen, and the system goes on PSS P0 state onto sleep mode, and it starts bleeding out electrons and data. The system is starting bleeding out electrons and data, and the collision doesn't happen. But the point is, 86 is not bad, but the interfaces are wrecked, and that are like M&A DIMM socket RAM, vanilla light or something. That's a special type of RAMs, and depending which RAM you have, if it's black carbon, if it's UDIMM, if CU DIMM, if it's M&A DIMM, which is not in product series like reference and stuff, the interfaces are different, and you fall into conflicts with functional CLL data like 86, and 86, which is okay, way better than 160 16, since that's the dead spot of the system, and 72 is usually not supported, since the graphics card usually have on the PCI, like on that height, a special chip, which are even way more intelligent than these brain clamps, where your RAM goes into there and to try to address the graphics card as for a socket, and this chip says fuck off, and your RAM lands behind there, maybe inside the PCI bridge, somewhere in between. It can find a place to socket it in. Completely depends on the architecture which there is, and we literally have like the 310 Neo, the 310 Z and stuff, maybe 3 other more, and we don't even have any capacities to exchange the RAM for a different interface RAM and to get one working. But the problem is, with these 7400 MHz, which are definitely better, you can scale down the megahertz towards 6000, 6400, 6800 and get to CL last digit 68, which is about there. That is a nice value, but the problem is when you want to run it on 7000 instead of 7400 on 76 or 72 or something, which is a nice place. These are black line products. Not M&A like these, but these are black line, not carbon one, but black products. And these have massive problems then with the light and fan solution. These don't find a right crypto enroll setting on the natural on itself, and you never will have a stable system. And when you turn ERP on, it will always lose connection and then flap back on P0 state into sleep bleed mode. That's 100% guaranteed. And the best thing which you can do is actually getting just RAMs which support 6800 megahertz and have maybe the last value a better value to underclock it back to 6400 megahertz or 6600 megahertz to a CL value on the last one, which you can work like 68, 72, 76 or something, or maybe even lower like 46 or something like there. But 68, when 68 on the last digit does work, the crypto enroll does work, and you can underclock it to still over 6000 megahertz, which is important for DRAM Nitro. Then you have basically a gold winner RAM, which where you can use the system in a well compassion, so that's not bleeding out or it's not like dead socketed to these dead clamps, which is a huge problem. And ERP ready supports systems like these clamps. So the wall system turns down and starts bleeding, it doesn't work, and it's in order to support these clamps, so these clamps do work, which is really important. And I've turned over to my system to disable ERP ready, enable SRVIO, and turn VDDIO to separate, so I can use the F clock or FLC clock to 4400 or 4600 or better 4800. 4400 is here about, 4600 is here till here, and 4800 is about here till there. And when you have 4800, which is good, then you can't really even put the CL on 116, but you have it to a supportive system of 86. That's actually important, or you have really good RAM and the system does work and you can actually clock it on 76 on the last. That would be working, would be nice on 2800 FC clock, but how do you know that it's working? It's really complicated since there's absolutely no data or something anywhere. But that is now on SRVIO on instead of ERP. That is on 2600 F clock, and UMCLK is on same clocks of the RAM or something, not divided by half. The NUMA domain is activated, not the CCX feature, because that's the 8-core processor with one CCX, that doesn't matter, but the NUMA domain, the extra attachment is enabled. That's really important. FCLK is 2600. I wanted to run it on 2800, but currently it is on 2600 and it doesn't boot with the fail message of 22. That's the debugging message. I will restart the computer by reset, and you can see the debugging, what it does. And 15 is also fail state where the fans don't spin, but it configures further back to 22, but the fans are never spinning in that configuration. And I'm really questioning what I should be doing here. The RAMs on 6400, I think, or 800 of the normal conditions, I think 6400. I don't really know, but it's on the CL last digits 76, and with SRVIO on, PBO is enabled on auto, not on auto, but from auto to enabled, just enabled, 0, nothing is spinning, and it's back to 22, and it stays like that, like so. PBO is activated. AMD overdrive is on advanced and auto, which is super important to actually activate. And when you put ERP ready systems on where you have these clamps and stuff then supported, then you can be sure that AMD overdrive doesn't really work. And you turn, when you put ERP ready on active, usually you turn down to AMD overdrive to set it on auto, active, or disabled, which could be an idea to do, but it's actually wrong. The wall system depends on AMD overdrive, and you put that on advanced and on auto, and nothing else works. I think that system currently is also LN2 mode activate, which does really look nice, and I think it's compatible, but I don't really know what these debug numbers are. Would be super nice when I would someone have explaining it what this mean and how I can get my system going on again, because I really like the system like it's right now with FCL clock on 2600 megahertz. With SRVIO activated, with VDDIO on separate, NUMA domain on active, and the TPM is currently hierarchy all enabled because it has to be like that. The AMD overdrive position is on advanced and auto then, and high position memory is on auto. The power down is on auto, and LN2 mode is on active. The DDR-RAM Nitro is also on active. And that's actually how the system should look like. But the ERP ready system of the Synapse clamps and stuff, and I don't really know 100% what systems are inside there, but the ACPI chip is also not inside the board, since it's an ATX board, and ATX boards don't have ACPI chips, that's for sure. But it has two SUC chips, and these I think don't really run correct, but these run kind of nice on that setting. That's the original setting, but I don't really know what I can do so the system starts booting again. Would be really nice when someone could see that, analyze it, and write down the comments of what these numbers mean, and what I can do so the fans do spin again and the system boots up, since I will use that system exactly like that. Even when I can't really be sure if the Krypton roll and stuff is supported, since the lower SoC chip is actually disturbed a bit, and I don't really know why that is. But that's super important. ERP ready. The ERP function doesn't work here. The system falls flat. PSS, P0 state, P1 state, or disabled is currently there, disabled. Theoretically wise, I could run that P1 state in exactly that setting and activate CSM on top, and that should theoretically work, but I don't know what the collusion is there. But PSS is actually super important, but not that important as ERP or ASPM eventually. ASPM is also disabled right here.